Hello children, let's have a recap of what linear inequations is all about. In case of linear inequations, as the term goes, it's inequation. Like, we've got an equation like 3x minus 5 is greater than 3, 3x is greater than 8, x is greater than 8 by 3. That's x is greater than 2/3. Now, depending upon what it belongs to, your solution set will come. That's a linear inequation. Inequation because it's greater than sign. So if it belongs to whole numbers, children, your answer would be 3, 4, 5, 6, 7. Because next whole number after 2/3, a proper whole number, children, would be 3, 4, 5, 6, 7, 8, like that. Let's just have a recap on that once again, children. Whole numbers are first natural numbers. It's 1, 2, 3, 4, 5, 6. All proper numbers, no decimals, no fractions. Whole numbers starts with 0, 0, 1, 2, 3, 4, 5, 6 till infinity. Integers given by symbol I or Z, integers given by symbol I or Z are from negative infinity, negative 3, negative 2, negative 1, 0, 1, 2, 3 till positive infinity. No decimals in between included. No decimals included anywhere in these, children. And all of these are to be denoted by the ones which exist by shading them. There's nothing like an open circle in any of these. If it's there, it's shaded. If it's not there, it's just not there. There's no shading required in that case. That's the way you denote natural numbers, whole numbers, or integers. But for real numbers, children, real numbers can only be written in set builder notation. So they are from negative infinity to 0 to positive infinity. All fractions, decimals, everything included in this. And it's always denoted by pipe. The not included pipe circle is open and the included one is shaded like this. Make it very clear, children. Don't shade it on the line. Shade it above the line so it's very clear for the examiner what you've exactly done. That's as far as the number line or the numbers are concerned. Please remember that. One important aspect in this is, children, if you've got negative x, for example, if you got negative 2x is greater than negative 4, children, we cannot just divide by negative 2 and not interchange the sign. We have to interchange the sign, children. So when you divide by negative 2, you will get x is less than 2. Or another way is, children, switch these two. Bring 2x here, bring 4 here. So we'll get 4 is greater than 2x. So x is less than 2. Either way, the answer would come to the same thing. But important thing, children, whenever you've got coefficient of x negative, whenever we have coefficient of x negative, make it positive by bringing it on the other side or change the inequality sign. Please remember that, children. This is an example to elaborate on this. Question says, solve the inequations and graph solution set on the number line. That's 2x minus 3 less than x plus 2, which is less than equal to 3x plus 5 belongs to real numbers. And of course, children, we'll also graph this on the number line. That's, we'll first take this part, then the other part. So 2x minus 3 is less than x plus 2 and x plus 2 is less than equal to 3x plus 5. Bring x this side, so x is less than 2 plus 3, that's 5. And here we get 2x is less than negative 3. That gives us negative 1.5 is less than x. And x is still less than 5. So when you combine this, children, on number line, if you imagine, this is x is greater than negative 1.5, so it's negative 1.5 or more. This is 5 or less. So the intersection would come out to be between negative 1.5 to x to 5, comma, x belongs to real numbers as it's been defined over here. And that's x such that it's between negative 5 and 5. And this is the solution set. X belongs to real numbers, children. Remember that. Now when you graph this on the number line, children, when you graph this on the number line, we mark all the values. Remember to do this by pencil, children. We need to show equal spacing and stuff. So this is 5, 4, 3, 2, 1, 0, negative 1, negative 2. Approximately over here, children, we get negative 1.5 and 5 would be somewhere over here. Draw a line connecting these two. Shade the in-between part. That's the relevant part that they want. They require, children. And negative 1.5 will be shaded since it's equal to also, children. So that's your number line. That's your number line. The solution on the number line, children. Remember that. Let's see another example to elaborate on this. Question says, if P is a solution set of 3x minus 4, which is greater than minus 2x plus 3, belongs to natural numbers, and Q is a solution set of 4x minus 7 is less than 10, x belongs to whole numbers, then find P intersection Q, take away P take away Q. Now children, before we begin with this, we'll first find what exactly P is and what's exactly Q. So for P, children, for P we'll get 3x minus 4 is greater than minus 2x plus 3, and P belongs to natural numbers, so that'll give us, children, 5x is greater than 7, x is greater than 7 by 5, so x is greater than 1.4. So children, here we'll get the solution set as numbers 2, 3, 4, 5. P is equal to 2, 3, 4, 5, 6, 7 till infinity. Now we'll do the same thing for Q, children. Q, which belongs to whole numbers, that's 4x minus 7 is less than 10, 4x is less than 17, x is less than 17 by 4. So that's 4.25, x is less than 4.25. So Q, children, accordingly, Q would come out to be, whole numbers, children, start from 0, so that's 0, 1, 2, 3 and 4. That's it. That's a possibility for Q. Now children, when they say write the solution set for P intersection Q between, that's A part, P intersection Q, will be, children, the things that are common to both of these, that's numbers 2, 3 and 4. Also you can write in the set builder notation, children, that's x such that x belongs to natural numbers. You can take natural numbers or whole numbers from 2 to 4. Both imply the same, children. A number line for this, children, a number line for this would be given as that's 4 is shaded, 3 is shaded, and also, children, 2 is shaded. So all these are shaded, children. That's it. We don't shade anything else, children. We leave it as this. Then they ask for Q take away P. So from Q, children, from Q you take away whatever it has in common with P. From Q you take away whatever it has common with P. So under that circumstance, children, 2 will go, 3 will go, 4 will go. So you'll be left with 0 and 1 only. So this would come out to be 0, 1. Can be written also as x such that x belongs to whole numbers between 0 and 1. So children, for this, the graph would come out to be on the number line. And 1. Then children, the question says P take away Q. So from P, the whole thing, we take away whatever it has in common. So what it has common, children, over here is 2, 3 and 4. Rest all of this is as it is. So that would come out to be in roster form 6, 5, 6, 7, 8 till infinity. In set build notation, it will be easier, children. X such that x is greater than 4, x belongs to natural numbers, whole numbers. Children, for a sum like this, we cannot mark till infinity, but we'll show a few and the rest will add on a big arrow showing that indicating it goes on forever. So that's 3, 4, 5, 6, 7, 8, 9 and 10 to give us 5, 6, 7, 8, 9 and 10, and a huge arrow over here signifying that it goes on till infinity. Indicating it goes on till infinity, children, because you cannot indicate any other way. So you put a big arrow there showing that it goes on till infinity. Let's see another example, children, to elaborate on this. Another question says, children, diagram represents two number lines A and B represent A intersection B and A intersection B complement on two number lines. Now, children, first let's write down in the set builder notation that what's A, what's B, and then let's get A intersection B and A intersection B complement, and then let's graph it. So that's first A, x such that x belongs to real numbers, comma, between -3 to 3. -3 included, 3 not included, because it's curved, it's round, so not included. Another rotation for this, children. One rotation is draw a closed circle and another rotation is draw an open circle, so that's the same as this. So -3 included and 3 not included. That's as far as A is concerned. Then for B, x such that x belongs to real numbers from -2, not including -2, to 4, not including that either. Now, children, the question says A intersection B. A intersection B, children, will be x such that x belongs to real numbers. Since both are real numbers, will also be real numbers, children. Intersection will be from -2, not included here, and included here, so will be not included. It's -2, not included, till 3, not included over here, included over here. So till 3. So that's x till 3. The number line for this, children, can be drawn. From 3 to -2, both not being included. That's A. Intersection B. Now they ask us for B complement. Children, B complement, first of all, B complement is from 4 onwards, including 4 till infinity, and -2 onwards till infinity, including -2. Since it's not there in this, it'll definitely be here, children. So now the intersection between A and this, children, A and this would come out to be from -2 to -3, including both, and from this part will not come in, children. There's nothing. Otherwise, you would have written two solutions at the intersection between them. So for now, first we'll add on B complement, children, so that it's easier for us to understand. That's B complement is equal to x such that x belongs to real numbers, comma, between x being less than -2 and equal union, because it's this or that, children, x greater than or equal to 4. That's B complement. Now intersecting that with A, children, that's A intersection B complement, children, would come out to be, when you look at this, children, as we discussed, it's going to be x such that x belongs to real numbers from -3 to -2 both being included. There is nothing else on the other side, children, because B complement starts from 4 onwards and there is nothing like 4 in A. So that will be your solution set. This you can just graph this by showing that's -4, -3, -2, -1, 0 and 1. From -3 to -2 both being included. This is also there. So is this. Thank you, children.